So in this question, what we have is we have a sphere that inscribes a cone, and there are certain specific cases are given. So radius of the radius of the cone has been given as small r. The radius of the sphere is given as r. The height of the cone. Now here actually the misleading factor is this particular height. Sometimes we think that the height has been given is only this much, but if you read the question, the height of the cone is h. It means that the height is from here until here. So that's the first information that we're going to use. Our objective is to show that the volume of the cone is this, and given that it has got enough stationary area, stationary volume, show that the volume comes out to be this much. So first part is to actually use our basic knowledge. Like now this length, if we see this particular length will be, because since this is radius of the cylinder, radius of the sphere, this is going to be, this length is going to be h minus r from here. Now if you apply Pythagoras in this triangle, this standing triangle, so this will be r square equals to h minus r the whole square plus small r square. Now since you can see that volume of the cone obviously is given by 1/3 pi r square h, we don't want r square, small r square. So it means that if I can make r square the subject of the formula from here, so r square will be capital R square minus h minus r the whole square. So you open up the bracket, r square minus h square plus 2hr minus 2hr plus r square. Open up the brackets, will become r square minus h square plus 2hr minus r square. So r square and r square get cancelled, and we get is 2hr minus h square. So this is capital R here. So 2hr minus h square is the radius square. Now this value, I'm going to put it out here. So if I put that, I get 1/3 pi, which was required for the outside. R square is nothing but 2hr minus h square times this height, as this height is already there. So if you take this h inside, it becomes 1/3 pi 2r h square minus h cube. And that's what we wanted to prove in the first part. Now they're giving that, they have given us that the cone has maximum volume. Now you show that this maximum volume comes out to be this 32 pi r cube over 81. Now what we will do is we'll differentiate. Now see here, the capital R is fixed. The capital R is a constant. So the only thing that is varying is the small a. What we'll have is we'll differentiate dv by dr dh will be 1/3 pi. Now derivative of this will be 4rh minus 3h square equate to 0. Now when we solve for h here, so this will be h, you can take common. So it'll be 4r minus 3h equals to 0. Anyway, 1/3 pi is a constant number. So we'll get from here, h is 4r over 3. So height is 4r over 3. And now what we're going to do is we're going to plug this height in the this particular formula. So what we get is volume will be pi by 3 2r as it is, h square will be into 16r square over 9 minus h cube, which will be 64 r cube over 27. And if you take the LCM of this and simplify, this will be 32 r cube. I'll just show the calculation as well. So this is going to be 32 r cube over 9 minus 64 r cube over 27, and pi over 3 is outside. And if you take the LCM of this, you will notice that that's the answer, which is 32 pi r cube over 81.